Yeah, welcome to our short video about digital secondary substations with our earth fault and short circuit devices EOR1DS and EOR3DS. My name is Gerald Jacob. I'm the product manager here for EORSys at our Eberle company in Germany. Yeah, what are the challenges we are facing at the moment in Germany? The goal of the government is to achieve at least 80% of energy generation up to 2030 out of renewable energies. Actual status by end of 2023 is 56%. Therefore, the wind power, the installed wind power shall be doubled, and the installed photovoltaic power shall be tripled until 2030. But not only the generation side, also the consumption side is changing a lot. So, for example, the heatings are changing from gas and oil heatings towards heating pumps. And on the other hand, the e-mobility is increasing rapidly. So at the moment in Germany we have more than 1 million electrical cars and around about 85,000 public charging stations. The goal of our government is to achieve a total number of e-cars to 2030 of 15 million and 1 million public charging stations. Yeah, what are the upcoming pain points of DSOs like Netze BW here in Germany that they see from this background in the medium voltage level? At the moment, compact switchgear stations and secondary substations are often not monitored at all. So the DSO has no measurements in the depths of the network. The grid situation is changing dynamically and several times a day, and therefore also critical situations can occur. And secondary substations are normally not remotely controlled. That means that critical situations cannot be solved quickly. Yeah, how to solve this situation? At first, I want to present our EOR1DS earth fault detection relay for simple secondary substations without remote control for additional monitoring in the depths of the grid. What are the key facts of simple secondary substations? They have often no SCADA communication to the central SCADA system. They are not remotely controlled. So somebody has to go there and switch in and switch off the cable fields. And if at least earth fault and short circuit indicator is installed, there's no communication to the central SCADA system. So staff has to go there and has to look for the direction of a fault. Our EOR1DS as a simple and cost-effective retrofit solution helps to improve the current status. So the device comes with 3 Rogowski coil sensors, and therefore you can have an undirected indication if you install it like this. On the other hand, you have the option to measure the voltage parallel to a voltage detection system like a CAPTIS or Vega system. And then you have current measurement and voltage measurement. You have the chance to get a directed indication of earth faults and short circuits. Furthermore, the device is capable of low power sensors like from the manufacturers Celisco, Greenwood Power or ABB with class 0.5. And with these sensors you get very accurate power measurements that you can also send to a central SCADA system via Modbus RTU. Yeah, here the main features in overview I want to emphasize, especially the possibility of fault records and logbooks that are saved on an internal SD card. and a wide range power supply of the device. So you can supply the device AC and DC up to 260 volts. In addition, the device has an internal long life capacitor installed where the indication of the device is guaranteed for at least 4 hours. Yeah, let's come from simple analog secondary substation to digital secondary substations, where we see our EORS3DS as a digitization unit for these secondary substations. The aim of the device is monitoring and control of important junction points in the grid. What are the key facts of digital secondary substations? On the one hand, they are remotely reported. So you get a complete condition diagnosis of the substation and measurement values of this special important grid node. On the second hand, you have the station remotely controlled. So nobody has to go there to switch in and switch out the load breaking switch, but you can do it from a central SCADA system. And these load breaking switch can be additionally supervised regarding safety and monitoring functions. Yeah, scope and requirements of these digital secondary substations. We have not to install 100% in the field digital secondary substation, but an amount of 10 to 20% is sufficient to have enough control in the network when they are remotely controlled. The topic scaling is very important because we are talking about several hundreds or thousands secondary substations in the field that shall be digital in a digital manner to have these sufficient control options. And furthermore, in the future, you have to take care of the fleet management. So you need a central software, for example, an MQTT IoT software to manage all these devices in the field to do firmware and parameter updates. Yeah, the EORS3DS has additional capability of low power sensors compared to our EOR1DS. The EOR1DS is only capable of sensors, low power sensors with 2-wire connection. These you can also connect at EORS3DS. Furthermore, there are also sensors on the market, especially from Siemens and from ABB. So bushings with integrated low power sensors that can be directly connected via RJ45 to an EORS3DS. Additional functions are available here, for example, and temperature monitoring of the bushing. The main features of the EORS3DS, again in the overview. Of course, the EORS3DS has some additional earth faults algorithms compared to the EOR1DS. So, for example, for reigniting earth faults. Fault records and logbooks are saved on SD card as well as they are readable, for example, remotely via our software or via a central IoT software. We are compatible with a very wide range of low power sensors, have free programmability, so a PLC functionality in the device, and the device is capable of a lot of standardized SCADA protocols like 104, 101, 103 protocol, 61850 Goose, DNP and Modbus. In addition to these traditional SCADA protocols, the device also supports MQTT IoT and MQTT management and operations, including a sophisticated certificate handling. The device EORS3DS has a DC wide range power supply from 20 volts to 148 volts because AC power supply is not so common in digital secondary substations because they are often power supplied by a battery. And here is as an example the digital secondary substation from the DSO Netze BW here from Germany, the new standard FFU 2.0. This is the very first true all-digital secondary substation. In all feeders and the transformer field, EOR3DS devices are installed, and in each field all analog signals are digitized locally. So all the binary inputs and all measurement signals are digitized by the EOR3DS. Each of these devices is connected in parallel by 3 different protocols, here shown as red, blue and green lines. The first one is the red protocol, a classical SCADA protocol, in that example 104 protocol for measurements, indications and switching operation commands. On the other hand, all this information and even further information come via IoT, this is the blue part, via MQTT. All this information are central broker where additional departments like asset management or network planning can subscribe these topics or data points. And last but not least, the green path, management and operations. This is a software for central fleet management, for central rollout of parameters, firmware and function updates. In the whole network of Netze BW, for example, or a DSO, there's in addition an EST server, enrollment over secure transport, because 2 MQTT-based protocols are encrypted via certificates, and there's also a 2-factor authentication via QR code implemented. Yeah, in the end, what is the benefit for the customer, for the DSO, to install these digital secondary substations? I want to mention especially 3 main topics. On the one hand, grid visibility. With these very accurate low power sensors of class 0.5, you get very accurate middle voltage readings in the central SCADA system, but not only in the central SCADA system, you get these values also via IoT for other departments like asset management or network planning. Second, grid automation. We want to lay the basis for autonomy functions in future, and the basis is a fault detection with directional indication. Capture all the switch positions, and you are also able to remotely control the cable fields from a central SCADA. Last but not least, cost-efficient operation. So this is the most important one, I think. If you are thinking of bulk remote parameter updates and firmware updates in future to have a solution for challenges that we know in 5 or 10 years, then it's impossible to go to every single station and do parameter updates. You have to do it from a central software. And as you can see in the diagram, of course, initially the costs are quite high because the infrastructure has to be paid and has to be created. But among the amount of secondary substations increasing, the costs per secondary substation is falling rapidly. Yeah, I hope you enjoyed our short video about secondary substations in a simple analog manner and in a digital manner. If you enjoyed this video, please have a look under our homepage. You can find us under LinkedIn, YouTube and Xing, and we would like you to register for our newsletter if you are interested in. Thank you very much.